Welcome back to the A320 Mentor channel. Today's masterclass covers a scenario every professional pilot should be confident with, starting the A320 NEO engines using an air start unit when the APU is inoperative or unavailable. We'll walk through the standard Airbus procedure for starting engine 1 first, using external pneumatic power. Starting an A320 NEO's engines without an operational APU requires precise execution using an air start unit ASU. This critical procedure demonstrates the aircraft's flexibility in various operational scenarios while maintaining safety standards. Understanding this alternative start method is essential for professional pilots who may encounter APU inoperability or MEL restrictions during their operations. The process begins with essential cockpit preparation. The aircraft must be properly secured with chocks in place, parking brake set, and both GPU and external pneumatic air connected to the fuselage connector near the left main landing gear. This setup ensures the aircraft remains stable and has access to necessary external power sources throughout the start sequence. The initial safety configuration requires several critical measures to protect both the aircraft systems and ground personnel. Both Pack 1 and Pack 2 must be turned off to prevent potential contamination from the ASU. Additionally, the APU bleed and both engine bleeds need to be disabled, while the cross bleed should be set to open. These settings create the proper pneumatic configuration for external air supply. Only after these conditions are met can ground crew connect the ASU, establishing the primary air source for engine start. For engine 1 start, which is the focus of this procedure, pilots must verify brake accumulator pressure before initiation. This check ensures adequate braking capability during the start sequence. A key technical requirement is maintaining a minimum starter air supply pressure of 30 pounds per square inch when the start valve opens. This pressure threshold ensures sufficient pneumatic power for proper engine rotation and start sequence, preventing potential hot starts or other complications. The procedure includes important safety considerations regarding external power management. A crucial warning emphasizes that disconnecting external power while the external power push button is on could harm ground personnel. Therefore, pilots must ensure the switch is set to available before requesting power disconnection. This safety measure protects ground crew during power transfer operations and maintains proper electrical system configuration. Following engine 1 start, the procedure branches into two possible paths, continuing with the ASU for engine 2 or transitioning to a crossbleed start. For crossbleed operations, specific steps must be followed in sequence to maintain system integrity. Request ASU disconnection when no longer needed. Set the crossbleed to auto for proper bleed air management. Activate both packs to restore normal air conditioning. Enable engine 1 bleed to provide air supply. Implement crossbleed start procedure according to standard protocols. The crossbleed engine start comes with specific cautions that must be strictly observed. It cannot be performed during pushback due to safety considerations and operational limitations. Simultaneous use of engine bleed supply with external pneumatic power is prohibited to prevent system conflicts. One engine must be running stably to provide sufficient air pressure for the second engine start, ensuring reliable ignition and proper start sequence. Before initiating the second engine start, several system configurations must be verified and adjusted. A PU bleed must remain off to prevent system conflicts. The supplying engine's bleed valve reopens while the cross bleed valve closes. The receiving engine's bleed valve stays closed to prevent reverse flow, which could damage pneumatic components. The pack on the receiving engine's side remains off to avoid increased ground idle on the supplying engine and ensure adequate air supply for the start. The final phase requires careful attention to safety and proper power management to ensure a successful start while protecting both equipment and personnel. 1. Confirm clear area around aircraft to account for increased jet wake, which can affect ground equipment and personnel. Second, set supplying engine thrust lever to idle to maintain stable operation. 3. Initiate start sequence for receiving engine following standard procedures. Fourth, monitor for potential automatic dry cranking indicated by cooling on EWD, which may occur based on engine thermal state. After successful start of both engines, the system must be reconfigured for normal operation. Return supplying engine thrust lever to idle position. Set the cross, bleed to auto for normal pneumatic system operation. Enable receiving engine bleed to establish proper air distribution. Activate both packs to restore normal cabin pressurization and air conditioning. Resume standard operating procedures for post-start checks and configuration. This complex procedure demonstrates the A320 NEO's robust design, allowing for engine starts even without APU availability. The sequence requires careful attention to detail and proper timing of each step to ensure safe and successful engine starts. The procedure showcases the aircraft's built-in redundancy systems and the importance of understanding alternative start methods. The ASU start procedure represents a critical skill in the professional pilot's repertoire, enabling continued operations during APU unavailability. This capability enhances operational flexibility and maintains schedule reliability when facing APU-related challenges. The systematic approach to the procedure, with its clearly defined steps and safety considerations, ensures consistent and reliable engine starts across various operational conditions. Understanding and executing this procedure correctly is particularly important during MEL operations or when facing ramp situations where the APU is unavailable. The procedure's success relies on proper coordination between flight crew and ground personnel, careful monitoring of system parameters, and strict adherence to established safety protocols. This comprehensive approach to engine starting demonstrates the sophisticated systems integration of the A320 NEO while maintaining the highest standards of operational safety. If you found this video useful, don't forget to like, share, and comment your experience with ASU engine starts below. We're building a global community of Airbus pilots and enthusiasts, and if you're not already subscribed, hit that subscribe button for more A320 NEO masterclasses from your trusted source, the A320 Mentor channel. Until next time, fly smart and stay sharp.